Hello everyone, my name is Anushruti Adhikari and I am from Bharati Vidyapeeth College of Engineering for Women. I am currently in third year and I am from Computer Department. So today I am going to present a DSBDM mini project based on the topic Music Recommendation System. So this is the user interface that I have created using Streamlit library, and through this interface we can interact with the recommender system. So we just have to select a song title from the drop down box and press on the show recommendation button and wait for the music recommendation system to recommend top 5 similar songs based on the user input. These are the top 5 songs which are similar to the input song that we have given. You can take another example. So after understanding the working, we are going to move to the code now. So this code consists of two main parts. The first part consists of data processing and the second part consists of building a music recommendation system using Streamlit library and the Spotify API. So our Streamlit library and the Spotify API both are in the app.py file. Streamlit is an inbuilt function of Python through which we can create creative user interfaces. And the later part, which is in the ip.ynb file. So this is where the actual recommendation system function is being written. So we'll start by initializing and importing all the important libraries such as the pandas, and then we're going to import the dataset as a CSV file and then print the top 5 rows of the dataset and the last 5 rows of the dataset to understand the dataset, whatever columns and the rows are there. Next, these are just few various data cleaning steps that I've performed to handle missing values or sampling the data and dropping the unnecessary columns. So over here is null.sum is used to check the null values in each row. As we can see, there are no null values in each row. There is no need to handle the missing values. Next, from the above dataset printed, we can see that the link column is not needed for recommending a song. So we are going to drop the link column from the dataset using this syntax. And then I have printed the top 10 rows to see if the link column has been dropped successfully or not. After handling and cleaning the data, we're going to move forward to tokenization. So before tokenization, we're going to see the data on which we're going to perform the tokenization function. So the text column data is where we're going to perform the tokenization function. So I've just printed the data to see what type of text is there. And then I have converted that data into lowercase, and by using this replace function, what I am doing is we are using a regular expression to replace any single word followed by a space at the start of the text with a single space. Regular expression r⁻w/s matches a single word character followed by space only at the beginning of the string. So after doing the needful, we are going to import the NLTK library. NLTK stands for Natural Language Toolkit library. And we are specifically importing the Porter stream, and after creating an instance of Porter stream, we're going to use the tokenization function. So before moving to it, we're going to understand the NLTK library. So the NLTK library is a very powerful library used for natural processing language in Python, and with Porter streamer imported and initialized, we can now use it to stem words in our text data. Stemming reduces words to the root or base form, which can be useful for tasks like text analysis and information retrieval. So next we are going to understand the function. So we have passed one input parameter in the tokenization function, and then we are going to tokenize each and every word. So this line over here, this function, is taking the input text and converting it into tokens and then storing it in a list of words, which is nothing but the tokens. And then through this for loop, we are iterating over each token in the list and applying stemming using the stem method of the porter streamer. This replaces each token with a stemmed form, and then we are returning the stem tokens by joining them back together with a single string separated by space. So now that we have defined the tokenization function, we are going to send the input elements for the tokenization through this syntax. So over here, this applies the tokenization function to each element of the text column in the data frame TF. The lambda function lambda x semicolon tokenization x is used to apply the tokenization function to each element x of the text column. Okay. So now we are going to move forward to importing TF-ID vectorizer, because we have now finished the tokenization process and we are going to move forward to recommendation process. So from the sklearn feature extraction.text, we're going to import the TF-ID vectorizer, and from sklearn metrics pairwise, we are going to import cosine similarity. So before moving forward, we'll understand what does the TF-ID vectorizer do. It is used to convert text data into TF-ID features, and the cosine similarity is used to compute the cosine similarity between the vectors. Okay. So next we are going to create an instance of TF-ID vectorizer, and this syntax over here, analyzer equal to word, it specifies that the feature extraction should be performed at the word level. This means that each feature will correspond to a single word, and the stop word equal to English. It specifies that the common English words such as stop words such as the, is, etc. should be removed from the text data. This parameter helps in improving the quality of the feature by filtering out the commonly occurring words that typically do not carry out much meaning or importance. So after creating an instance, what we are doing is this line over here. This line applies the TF-ID vector to the text column of data frame DF, which contains the textual data. The fit transform method computes the TF-ID values for each word in the text and constructs a sparse matrix where each row represents a document and each column represents a unique word in the entire corpus of the document. The value in each cell of the matrix corresponds to the TF-ID score of the word in that document. Okay. So after calculating the TF-ID score, I have printed the matrix over here, and then we are going to move forward to the similarity concept. So before moving forward, we are going to understand the concept of cosine similarity. So what is cosine similarity? It is used as a metric for measuring the similarity between two vectors or documents. So how does it work? In NLP tasks such as document clustering, text classification, and information retrieval, documents are often represented as vectors using techniques like TF-ID. Cosine similarity is then used to measure the similarity between those document vectors. This allows for tasks such as finding similar documents. So next what we are doing is we are using the cosine similarity function to compute the cosine similarity matrix based on the TF-ID score or the matrix. So here each element, which is nothing but the similarity ij, represents the cosine similarity between the ith and the jth document, and then we are going to print the cosine similarity 0 over here. So this line accesses the cosine similarity score of the first document with all the other documents. It retrieves the first row of the similarity matrix. So what is going over here is we're going to compare the first document with all the other documents, and this similarity score will be stored in the similarity matrix. So this is for the column I is equal to 0. So for the row j is equal to I is equal to 0. So, and furtherwise, if you go to I is equal to 1, then the second document will be compared with all the other documents, and the score will be calculated and stored in the similarity matrix. Okay. So over here I have just checked if the problem is extracting the correct song title. So as we can see, after passing the song title Crying Over You, the data frame is able to extract that song title and display the description. So now we are going to define the recommendation system function. So over here we have defined a function called as recommendation, and we have given it one input parameter. And next line over here is taking the song title as an input and locating its index in the data set. So what is happening over here is that song df represents a song title for which recommendation has been made, and then this line over here retrieves the index of the input song in the data frame df, and then this line over here it calculates the similarity score between the input song and all the other songs in the data set. The enumerate function is used to generate pairs of index and similarity score. These pairs are then sorted in descending order based on the similarity score and stored in the distance. Then we are defining a variable song, and then we are going to start the process of retrieving the top similar songs. So the for loop over here, this line iterates over the sorted similarity score starting from the second element up to the 20th element. The first element is skipped as it represents the song itself, and then we're going to append so within the loop it retrieves the song title corresponding to each index from the data frame df and appends this song to the song list, and then we are finally returning the list of recommended songs excluding the song input song itself, which are similar to the input song based on the cosine similarity score. So the similarity scores are calculated, and based on that we're going to sort these song titles, and then we're going to extract the song and return it. The next line over here, we're calling the recommendation function and passing. After calling the recommendation function, we're going to pass the song title, which is Crying Over You, and then it is going to recommend the songs. So over here what is happening is we are displaying the similar songs. And then lastly we are importing the pickle library. So the pickle library over here is used to serialize and deserialize Python objects. Serialization is the process of converting a Python object into a byte stream, while deserialization is the reverse process of reconstructing the Python object from the byte stream. So these lines over here uses the pickle module to serialize and save the Python object, specifically the similarity matrix and the data frame df to the disk. So we'll just revise what we have done over here. First we started by importing the pandas library, then we stored the data set as a CSV file in the data frame df, and then we perform some data cleaning actions, and then we have dropped all the unnecessary columns to reduce the size of the data set and make the system more accurate so that the recommendation system can accurately recommend the songs. And then we have performed tokenization over here. So before performing tokenization, we have made a base by making the data more readable and easy to process. And then we have performed tokenization on each and every word in the text column. And then we have imported the TF-ID vectorizers library and calculated the score, the TF-ID vectorizer score, and stored it in a matrix. And then we have calculated the similarity score between each and every document, and then we have written the recommendation function to recommend the songs based on the similarity score. And that's it. This is the IPYNB file, which is consisting the main recommendation process code. I hope you all have understood it. Thank you very much.